what to say, Ghazipur Lanfill, if you see it is burning, you can see the flames that is coming out. They have just inserted these pipes on top of the landfill. This is like close to 70-75 meters high, and it's just burning over I don't know how many years. So this is very risky. Luckily, people, I don't know, some people when the gas was coming out, they just I think lit it, and from that time on, it's like going on. So these kind of things can be very risky. So you can imagine how much amount of methane that is stored beneath the waste. If you use it as a fuel or if you can tap it properly, then that can be a good fuel as well. So the formation of the fire triangle, as I said, is the availability of oxygen, because for fire to occur, there must be a certain amount of oxygen, certain amount of fuel, as well as heat. So, of course, in the form of organic waste, you have the fuel, and you have the oxygen. Oxygen does penetrate into the landfill surface to some extent, and then, of course, you have the heat that is already there due to the chemical reactions. So the other things that are there is like the methane, that is also a fuel as a secondary fuel. Then oxygen intrusion. Then after that, this thing occurs. This is all what to say spontaneous ignition that occurred at a landfill in Delhi called plant. So if you go into the biological part, as we know, the organic part contains something called a cellulose, semicellulose, and lignin. Usually the lignin part doesn't degrade. The cellulose part degrades completely. So the content of cellulose is nothing but glucose. When this degrades, there is a huge amount of energy that is produced. It's an exothermic degradation or reaction. As a result, methane and CO2 are produced, and this is totally called the landfill gas. And because of this, all these things happen, and then there is a landfill fire, and then there is a disaster. So here fresh MSW contains a large quantity of organic content, whereas if you take a partial thing, it's like almost half, and the whole thing also contains, but it's like less than 15 or 20%. The organic content in the fresh waste is around 75% in Bangalore, just to give an idea of how much it is. So this is the reactions that I was talking about, heat production. This is aerobic degradation. If you take this is glucose, nothing but cellulose or glucose. When there is an aerobic reaction, this is what happens. This much amount of energy is released, and then when there is an anaerobic degradation, the amount of energy is released. This is much minus 9 indicates the exothermic one of the release of energy. And when there is a chemical oxidation, say for example iron or metals, whatever is there, it gets oxidized, and then this amount of energy is released. So when all this energy is released, this is like if you can say per atom or per mole of waste rock, the component. So when these energy is released, this heat, if it doesn't get dissipated properly or removed properly, this is what causes a spontaneous ignition. So if you take some literature, as early as 2009, this fellow he characterized the spontaneous fires in landfill. It was not in India. It was done with the help of a muffle furnace to find out proper ignition temperature. Proper ignition temperature is nothing but the temperature at which the fire, the components or the waste component catches fire. Then he found out that the AAT of dry waste is around 267 degrees. So if you can imagine, does it really go up to 267 degrees in order to catch fire? You'll see that. Now coming to MSW, that is like 10-20% moisture content by weight had this much. So the increase in 10% if there is moisture content is 10, then this increased to 355, and the 20% moisture content increased to almost 400 degrees, which is quite high. So the average was between 200 to 350 degrees. So this is one of the landfill locations. You can see this is Lanfill. This is the top. You won't be able to guess the height of it. You can see the settlements over here. And if there is any slip or any failure of this, because of the heat or because of the fire, the whole thing will slide down here or this side, causing a catastrophe, a major disaster. And that is why now Delhi is, I think the local is with the chief engineer also. And person, so he was telling that they're going to start the biomining part, and they started it, but then again it remains close to us to be seen that how effective it is. So this is how it is. It looks like this is this is some spontaneous ignition that is happening. You can say smoldering process. So can see, the fire or the spontaneous smoldering doesn't happen everywhere. Only where this fire triangle thing comes up, or the optimum conditions are there, now and then, here and there, it ignites or it smolders. And this smoldering continuously, if it is left noticed or unnoticed, um, gradually develops into a fire. So we can see we did some measuring part. What is the temperature? If you see, where there is a smoldering happening, the temperature is around 258. This whatever I showed the pipe, it was around 369, and here also the temperature was around 260. There is one more landfill called Lanfill. So whenever there is a smoldering happening, the temperature does go up to this much. So if you see, we rounded off the objective sites as determination of the composition in the landfill, because each and every landfill has a different composition. There is a variation. Then the physical and chemical properties of waste, then determination of the auto-ignition temperature of the ignition temperature of different waste components. Because in India it is quite heterogeneous. Maybe the paper part catches fire first, then later on the other parts like cardboard or other things. And then so there was a need to study the emission temperature of the different waste components in detail. Then the effect of moisture content on the composition, because raise in moisture content by or increase in moisture content by 10% resulted in almost doubling the ignition temperature. So the effect of age of landfill waste also was studied, because the more the age, the more prone it was to landfill fires or smoldering. So this is the waste composition of the three types of waste. That's fresh waste and 1 month old waste, 1 year old waste. So if you can see what is a major thing. So the organic plus soil is around 40% here. That has come down very heavily here. Here what happens is the already remaining waste at the bottom of the landfill adds up to the organic content, and the other components slightly decrease, because as it reduces or as it degrades, the volume reduces. Then if you take a 1 year old waste, then the soil part or the soil like organic content is more, and the other components are more or less little bit similar compared to the initial of the 1 month old waste. This is one more landfill pass where the similar composition was was found here. As you can see, the initial was around 40-45%, and then that increased to soil and organic content here, and then 1 year old waste is 50% of soil plus organics. So if you see the pH value, why pH value? Because even if it is acidic, that also causes a spike in the temperature, and then because of that there is a heat, and then there is fire. So if it is alkaline, usually there is no fire or there is no temperature rise. So if you take this landfill fresh waste, it was around 7.72, and as the age of the waste increases, the alkalinity also increased, or the pH also increased. So if you see 1 year old waste almost had close to 9, which is a very high pH or alkaline pH. But then if you see fresh waste, this is not only in Balswa, even in other landfills also, the fresh waste had a very less pH, indicating that it is acidic in nature and also can contribute to effective heat generation or temperature rise. So this is coming to the moisture content of the waste. If you see the fresh waste, it almost has 50% moisture content, but then if you take 6 month old waste, it's like 5%, and then 1 year old waste is around 2 to 3%. So this is one of the major reasons why there was such frequent incidences of fire, because the lesser the moisture content, the more prone it is to the heat or the fires or smoldering, and the easier it is to catch fire. If you take the Gazipur landfill, a similar thing was found. The moisture content was more than 30, and then subsequent 1 month and 1 year old was very less. So there was a plant, that is waste to energy plant in Gazipur, that was taking waste and it was trying to utilize it in a thermal process, converting it into energy. The moisture content of that waste was around 15%. The efficiency of this plant was also not good because of the moisture content. That is what we try to explain there. That the result that you have a moisture content less than 10% or 8%, the waste to energy plant is not going to work effectively or efficiently. So if you see the relationship of moisture content along with the age, so the synthetic waste or the fresh waste has a very high moisture content. This is comparatively less, because when we monitored it was around 75, here it is like around 50, 55. Then as the age increases, the moisture content also